Today's Daily Dose of Math is about Principle 13 from the MTH-4273 geometry course. Principle 13 states that the length of the altitude to the hypotenuse of a right triangle is the geometric mean between the lengths of the segments of the hypotenuse. This principle, along with many others, is attached to the final exam that the student writes for this course, and that's helpful because when justifying steps in their calculations, the student, instead of having to write out this whole sentence, is able to say, I'm using Principle 13. But the text by itself isn't very useful in helping the student to remember how to apply it. The text printed on the exam does not include this little formula or diagram. But this student in this course is allowed to make a memory aid, a sheet of paper that has formulas, examples that are helpful to the student in the exam. And I encourage students to include a diagram or maybe an example with the values filled in to remind them how to apply this. The best reason for that is that there are a couple of other principles in the same course that are kind of similar to this one, and it's easy for the student to get them mixed up. So having them printed in text on your exam helps you to avoid mix-ups, and having the little example on your memory aid helps you to remember how to apply it and not accidentally apply one of the other ones. This video is not showing how this was derived or explaining really how it works. It's just showing some examples of it being used in action. In question A, BH, the shorter segment of the hypotenuse, is 2 units in length. CH is 8 units in length. That's the longer segment of the hypotenuse. And AH, which is the altitude, is our unknown. So we fill in this little formula with the values we have. AH squared has to be equal to 2 times 8. AH squared, therefore, has to be equal to 16. So AH is equal to the square root of 16, which is 4. No units were given in the question, so I use the word units as my unit. And I'm finished answering the question, except I haven't justified it. And I justify it simply by saying I'm using Principle 13. I encourage students to write the number 13 and put a circle around it to make sure I notice it when I'm correcting. So the math of using this thing is very simple, very short and sweet. We just want to make sure we don't accidentally mix it up with one of the other similar principles. In question B, we know BH, which is the shorter segment, and AH, which is the altitude, but we're looking for CH, the longer segment. AH squared becomes therefore 8 squared and is equal to 4, which is BH, times x, which is our CH. 64 is equal to 4x. We isolate our variable, and x is equal to 16 units. And I remember to say I'm using Principle 13. I used it twice, I should be justifying twice. In question C, CH, the longer segment, is 12, AH, the altitude, is 6. How long is BH, the shorter segment? 6 squared is equal to 12x. 36 is equal to 12x. We isolate our variable, and x is equal to 3 units. And I'm using Principle 13, so I say so. One more note is to point out that if you're studying this same math in a different curriculum, you may have a list of principles and theorems that you're using. You may have this one, but it might not be number 13 in your list. An example of that is the fact that this is the Advanced Secondary 4 geometry course that I teach in my classroom, but I also teach the Basic Secondary 4 geometry course, which is called Math 4153, and it has a list of principles and theorems. It has this one, but it's not number 13. The other course has less principles and theorems for the students to know, so the numbering system is different, and this is actually Principle 11 in that course. Just be careful to use the list of principles and theorems that goes with your course. That is today's Daily Dose of Math. Please like, subscribe, and share.